Hello students, welcome to our channel The Bridge to Success. We are here to do the chapter Quadrilaterals of class 9th. So first of all, to start with, what do you mean by a quadrilateral? Quadrilateral can be defined as what? A four-sided polygon having four vertices, four angles. Okay, four vertices, four angles, two diagonals. Okay, so this is what quadrilateral is all about, and quadrilateral has its types. So what all kinds of quadrilaterals are there? It can, first of all, it's a trapezium. Now what's a trapezium? A quadrilateral in which one side, one pair, sorry, in which one pair of opposite sides are parallel. Okay, so this is what the figure is going to be like. Over here, what can you see? ABCD is a trapezium. So you can see the parallel sides. This perpendicular distance clearly says that the lines are parallel. So we will write that in this AB is parallel to AB is parallel to CD. Okay, right. Then we know what next? Then we have a parallelogram. Parallelogram. Now, what is a parallelogram? A quadrilateral in which we can say opposite sides are parallel. But apart from the opposite sides, there are other properties as well. This will be doing as we head towards the chapter, right? As we move ahead, we'll be doing each and every property of parallel. So quadrilateral in which opposite sides are parallel. So let's make up a parallelogram. Okay. Over here, what can you say? ABCD is a parallelogram. As per the definition, we can say AB is parallel to CD and AD is parallel to BC. Okay. Now, parallelogram further has its types. If we really study about that, so there are few four-sided figures which are defined as parallelograms. First one we can say rectangle. Now, what is rectangle? It can be called as a parallelogram. It is a parallelogram. Now, this is a symbol for parallelogram. I'll be using further as well, in which all angles are right angles. Let's make up a parallel rectangle first. So what do you see in this case of a rectangle? That all angles are right angles. A rectangle is called as a parallelogram as well. If we say that rectangle is a parallelogram, it clearly means that it holds all the properties. It has all the properties of a parallelogram. Okay. So, what is a rectangle? It's a parallelogram in which all angles are right angles. So angle A, angle B, angle C, angle D, all are right angles. Okay. And there's one more property added to it. The diagonals are equal. This also you must have done in your class 8 in chapter quadrilaterals. Okay. The diagonals are equal. We can clearly say that AB will be equal to AC will be equal to BD. Okay. Now, apart from rectangle, there's one more figure called as a parallelogram, which is known as a square. Now, what are the properties of square? Properties of square. A square can be called as a parallelogram. It is a parallelogram in which all sides are equal and all angles are right angles. And one more property that separates it from rectangle is that the diagonals bisect at 90 degrees and the diagonals are equal to. Okay. So the diagonals are also equal in case of a square. So we can actually say that square is a special form of a rectangle. Why do we say so? Just note it, please. Because all the properties of rectangle prevails in case of square as well. How? In a rectangle, opposite sides are equal. Or in square, all sides are equal. We can say the opposite sides as well. We can say AB is equal to CD and all angles are 90 degree in case of square as well. And one more things, diagonals are also equal. And something that separates it from a rectangle is that the diagonals bisect at 90 degree. Okay, which clearly means AO is equal to OC and OD is equal to OB. Okay, okay. Chalo. Let's move ahead to the third form of a parallelogram, which is known as a rhombus. Now, what is a rhombus? You must have done in your previous classes as well. A rhombus is also known as defined as a parallelogram. Let me tell you. It's somewhat like this. Okay. It can also be called as a parallelogram in which all sides are equal. This might give you a hint that there is one more parallelogram with all sides equal, that is square. Let us see how rhombus differs from square. All sides are equal means AB is equal to BC is equal to CD is equal to AD. Okay. So rhombus can be called as a parallelogram. Rhombus is a parallelogram in which all sides are equal and diagonals bisect at 90 degree. Okay. But what is how it is differing from square? In case of square, all angles are right angles, but in case of rhombus, it is not possible. Okay. So, but if you see the square, let's check it out. Here also the diagonals are bisecting, and here also all sides are equal. So there can be one more point that square is also special form of rhombus. Why we say this? Because it holds all the properties of a rhombus. That's why all sides are equal and diagonal bisect at 90 degree. I hope these points are clear. Okay, we are done with the types of parallelograms. Now, one thing of quadrilateral that I was supposed to mention, that angle sum property of a quadrilateral is angle sum property. If you say angle sum of all the angles of the quadrilateral is 360 degree. Sum of all angles of the quadrilateral is 360 degree. Okay. Now let's head towards the theorems of the parallelograms as I was talking about earlier. Theorem 1. Theorem 1 clearly says that diagonal divides a parallelogram into two congruent triangles. What does it mean? Let ABCD is a parallelogram. Let us construct a parallelogram first. It says the diagonal divides a parallelogram into two congruent triangles. ABCD is a parallelogram given ABCD is a parallelogram in which AC is a diagonal. So what basically AC is doing, dividing the parallelogram into two congruent, two triangles. We have to prove them those divided triangles as congruent. To prove is normally children, if the opposite vertices of the quadrilaterals are joined, so the quadrilateral gets divided into two triangles. Now this parallelogram is also a quadrilateral. It is getting divided into two triangles. So to prove triangle ABC is congruent to triangle ADC. How to prove that? See, in triangle ABC and triangle ADC. Now, as you know, that the angles, triangles, the opposite sides are parallel. So with this, I can simply say angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Okay. So in triangle ABC, I can say angle 1 is equal to angle 2. Why so? Alternate interior angles. Then kids, AC is common. AC is equal to AC is common. And angle 3 is equal to angle 4. This is also alternate interior angles. So what we can say about this congruency, the triangles are congruent by angles, side angles. Therefore, triangle ABC is congruent to triangle ADC by angle, side angle. This is what we had to prove. I hope this is clear. So this theorem says that in a parallelogram, opposite sides are equal. So to prove this, let us see what is given in the question. Given is that ABCD is a parallelogram, okay, and to prove that AB is equal to CD, AB is equal to CD, and AD is equal to BC. Now, in order to prove this, we need to construct a diagonal, right? So what we'll do, we just try to join two vertices. Let us join AC in this case. Okay. Join AC. Now, if we look into these two triangles, what do we see? The given thing is that ABC is a parallelogram, and as per our first theorem, a diagonal divides a parallelogram into two congruent triangles. So we can say that the triangle ABC is congruent to triangle ADC. Reason being, a diagonal divides a parallelogram into two congruent triangles. Okay. Now, since the triangles are congruent, we can simply say that AB is equal to CD and AD is equal to BC by CP CT. I hope this is clear. Now, let's head towards the third theorem. It says in a quadrilateral, if opposite sides are equal, then it is a parallelogram. So, what is given? Given is that ABCD is a quadrilateral in which AB is equal to CD and AD is equal to BC. And we have to prove that ABCD is a parallelogram. How will we do that? Again, because it's a quadrilateral, we need to construct a diagonal also, as congruency is going to help us out in proving this quadrilateral as parallelogram. So we'll simply say join AC proof. Let us take both these triangles into consideration and let us mark the equal things. AB is equal to CD and BC is equal to AD. So we'll simply say in triangle ABC and triangle ADC, AB is equal to CD, it's given. AC is equal to AC, this is common. And AD is equal to BC, this is, rather we should say, because we've written ABC before, no, so we should say that BC is equal to AD, this is given. So we can say that the triangles are congruent by which congruency? SSS. Now, since the triangles are congruent, you have the liberty of saying that angle 1 equals angle 2 and angle 3 equals angle 4 by CPCT. Angle 1 is equal to angle 2 and angle 3 is equal to angle 4 CPCT, corresponding parts of congruent triangles. See children, if you look into this thing, what you will see? Angle 1 and angle 2 are actually forming up the alternate interior angles. So I can simply say that angle 1 is equal to angle 2 and angle 3 is equal to angle 4. They are the pair of alternate interior angles. Therefore, I would say that AB is parallel to CD and AD is parallel to BC. AD is parallel to BC. Now, since opposite sides are parallel, we can say that ABCD is a parallelogram. I hope this thing is clear. Now, the next theorem says that in a parallelogram, each pair of opposite angles are equal. What does it indicate? That angle A is equal to angle C and angle B is equal to angle D. But children, we have a precondition that the quadrilateral has to be a parallelogram in this case. Okay, so let's move ahead and prove this. Given is that ABCD is a parallelogram, okay, to prove angle A is equal to angle C and angle B is equal to angle D. Okay. So let's see how we're going to do it. But for proving this, we can actually take any diagonal. So we can say for now that join AC. Now, since ABCD is a parallelogram, can I say that triangle ADC is congruent to ABC as per our first theorem that a diagonal divides a parallelogram into two congruent triangles? I will simply say since ABCD is a parallelogram, we can say that triangle ABC is congruent to triangle ADC. The reason a diagonal divides a parallelogram into two congruent triangles. Now, since the triangles are congruent, you can say that angle B is equal to angle D by CPCT. Okay. Now, if you have to prove angle A and angle C as congruent, then you will have to join this BD. Okay. I think I'll just give you a brief explanation about it. Rest you can do it further. If we join BD, we can simply say ADB is congruent to DCB as a diagonal divides a parallelogram into two congruent triangles. So by that we can simply say angle A is equal to angle C by CPCT. So I'm just writing over here. Similarly, angle A is equal to angle C. Okay. I hope this theorem is clear. Let's move ahead with the next theorem. In a quadrilateral, if each pair of opposite angles are equal, then it is a parallelogram. It is just the opposite of the theorem we did before. So given a simple that ABCD is a quadrilateral in which angle A is equal to angle C and angle B is equal to angle D. We have to prove that ABCD is a parallelogram. So Let us mark it what is given in the question. Angle A is equal to angle C and angle B is equal to angle B. Okay. So proof angle A plus angle B plus angle C plus angle D is equal to 360 degree. As I told you, angle sum property of quadrilateral. Okay. Now angle A is equal to angle C. So instead of angle A, I can angle C, I can write angle A. And instead of angle D, I can write angle B as angle B is equal to angle D. So we come to the situation where we have 2 times of angle A plus 2 times of angle B is equal to 360 degree. Angle A plus angle B 2 times will be equal to 360 degree. I put 2 as common. So angle A plus angle B will be equal to 180 degree. Now children clearly see if angle A plus angle B is 180 degree, we can say, but they are the pair of co-interior angles. Therefore, AD is parallel to BC. Okay. Similarly, in the same manner, we can prove that angle B plus angle C is equal to 180 degree. See, the situation is just going to be the same. We just need to convert everything into angle B plus angle C. Angle A can be written as angle C, angle B, angle C can be written as angle C, and angle D can be written as angle B. Okay, 2 times of angle B plus angle C is equal to 180 degree. Angle B plus angle C will be equal to, sorry, 360 degree. It's going to be 360 degree. So angle B plus angle C will be equal to 180 degree. Again, if you see the figure, if angle B plus angle C is 180 degree, I can simply say AB is parallel to CD. They are the pair of co-interior angles. Therefore, AD is AB is parallel to CD. Okay, I hope this is clear. So from equation 1 and equation 2, from equation 1 and equation 2, we can say that ABCD is a parallelogram. Hence, proved. I hope this is clear. I hope this part is absolutely clear and all the theorems that we have done before are clear. The next theorems we'll be doing in the theorems, leftover theorems we'll be doing in the next video. Kindly just go through them and try to do it by yourself, right? Thank you so much.